Hello, I'm JW. Today we're going to have a look at back boxes, as in this metal one in this fake wall I've got here, and whether or not it's necessary to attach a lead from the terminal in the box to the back of the socket, as in something like that, or whether you can actually rely on the fixing screws which go through the front of that and are actually connected to the earth connection on the back anyhow. And of course then there's that thing about whether the lug is fixed or moved and all of that. Now we've got this demonstration wall here. We're going to have a look at some possible options with that later. Now first of all, where is this covered in the wiring regulations, this being the 18th edition, a fairly substantial volume? And the answer is nowhere, because nothing in here actually says that you need to connect a wire to the back box, or in fact connect anything to the back box at all. There's simply nothing in there whatsoever. Where this thing about the fixed lug and variable lug and whatever else comes from is actually in this book, which is Guidance Note 1, which is part of a whole set of these things which you can buy to go with this book. So first of all, we're going to have a look in here just to see what it actually says, and then see how that can be applied to a socket such as the one we've got here. So if you have a look in this book here, this is the wiring regulations. You won't find anything in there regarding metal back boxes or connecting fly leads to them or using a fixed lug or any other kind of lug, mainly because there's nothing in there that covers that. And then the question is, do back boxes need earth connections at all? Because are they exposed conductive parts? Well, they're certainly conductive parts because they're part of the electrical installation, as they have cables and things in them. And of course they're conductive because they're made of metal, galvanized steel in most cases. However, are they exposed? And the answer is no, because of course they're buried in the wall, so you can't get to them, and then the front of it is covered over with the socket or switch or whatever else you've got. Now in the case of this metal socket, the socket itself is an exposed conductive part because it's made of metal, but of course this is connected to earth anyway by virtue of the earth terminals on the back. If it's a plastic accessory, such as this thing, then the screws are going to be exposed conductive parts because again they're right on the front there, but again the screws are connected by the metal pieces on the back going to the earth terminal. So once that's in place on the front, none of it can be accessed whatsoever. The box is completely covered in the wall, and these are also larger than the box as well, so there is a significant overlap there. So theoretically the back box is not an exposed conductive part and doesn't need earthing in the slightest. However, that's in theory, and as is often the case, reality may be different. Now this book we're going to get rid of because it doesn't really help us in this circumstance, but what might be more use is this book, which is Guidance Note 1. There's a whole set of these if you want to buy them, and this particular one covers selection and erection of equipment. So have a look inside this one, and there's a whole section here on this very thing, earthing of flush metal accessory boxes. So what we've got here then, this is in section 384, maybe slightly different depending on what version of this book you've got, as it's updated fairly often. So as it says here, it's been questioned whether flush metal accessory boxes come within the definition of exposed conductive part, which is just what we were saying. So exposed conductive part is as defined here in part 2, conductive part equipment which can be touched and which is not normally live but can become live under fault conditions. So yes, the back box can, but you can't actually touch it because, as I said there, it's completely enclosed in the wall, and that's basically what it says here. And then we've got, however, the IET, which, in case you don't know, is the people that publish this particular set of wiring regulations, takes the view that flush metal accessory boxes should be considered to be an exposed conductive part and connected to the main earthing terminal by means of a circuit protective conductor. So though technically the definition doesn't cover them, then the general view here is that you certainly should connect them, and that's pretty much shared by anyone else who does electrical work to any kind of standard. Where an accessory does not have an earthing terminal incorporated, such as certain light switches, the circuit protective conductor should be terminated at the earthing terminal in the accessory box. And by light switch we're generally meaning things like this, where you've got the connections to the switch itself on the back, but of course there's no earth terminal provided, and notably the screws don't connect to anything either, it's just through the plastic front there. So that's the situation there. Now in the case of other items like this thing, for example, this does have connection to both screw holes on the back there, so the metal around the fixing points there and also on the front as well. So you put screws through there, they're going to be in contact with that, and that metallic part is connected to the earth terminals which are on the sides on this particular one. And we've got here that says when accessory has an earthing terminal incorporated, The protective conductor should be connected at the earthing terminal. Well, that's pretty obvious. Accessories have an earthing terminal incorporated, such as socket outlets. Normally have an earth strap connecting the earthing terminal to one or both of the fixing holes, both in the case of quality items, only one with other shoddy things we've seen previously. And flush metal accessory boxes usually have at least one fixed lug, which we'll look at in a moment. And the IET suggests that such boxes are effectively earthed via the tight metal contact to the fixing screw in the fixed lug. So unless both lugs are of the adjustable type, it's not considered necessary to connect the earthing terminal of the accessory to the earthing terminal in the metal accessory box by a separate conductor. However, it does then go on to say that where there's any doubt about the continued effectiveness and so on, then you should put one in anyway. So basically saying you don't need it, but on the other hand it says you probably should. There's also notes at the bottom here about when it's in a conduit system. We'll look at that separately as well. Now there's a picture over there, but instead of a picture we can just look at the real thing, which will be slightly more involved. Now here we've got a socket box, and it's already been fitted in this fake wall, and these cables coming out of course are not connected to anything, so we're not going to be doing any dead testing or whatever, because these are not part of any extra installation. This is just a demonstration. So this is the kind of situation you might find after first fix and the plaster has been in and has cleaned it all up for you, just like they don't do in real life. And here's our metal box. This is a 2-gang box designed to fit a socket or whatever on. That might be something like that. Now we can see in the back of this one it does have an earth toner down there at the top left there, so provided for the purpose, and in fact most boxes do have these in the corner there. Now in terms of the lug, whether it's fixed or not, what it's talking about are these things on the side here, and those are where your fixing screws go in. So here's our double socket, screw either side, and those go into the things there on each side. Now this one of course is fixed because it's solidly in there. It doesn't actually move, it's actually just a piece of metal bent out the side of the box. The one over the other side, however, as you can see there, is fairly loose because it's a separate piece that's just been clipped under a little tab that's been folded over, and the purpose of that is so you can put your socket on the front, and that gives you a bit of adjustment to get it nice and level on the front there. So the book there, the IET one, basically says that if it's got one of these, and crucially on the socket itself you've got that earth strap coming over to the holes, then you can just rely on this and not bother to connect to the thing in the back there. Now most sockets do have the two on the back like that, and again we saw this single item here again on both sides on that one. However, we did see earlier that a certain socket did not have it on both sides, it was only on one side, so that would be a bit shoddy if you found it was on the side of the adjustable lug. And a long time ago we did see a horrid socket which had a 3-letter brand on it, which didn't have a strap going over to either terminal, so that would certainly be a fail in that situation. But assuming you're going to buy semi-decent items and they have a fixing on both sides, according to that book you don't need to attach to that thing in the back, you can just rely on the fixing screw. However, just doing the bare minimum is not really the best choice, so generally probably a good idea to actually use that. And in the case of things like, say, a light switch, which almost always do not have any earth terminal on the back, it just has the plastic there so there's no connection, then for these you definitely would need to connect to this, because of course first of all there's no terminal on the back of the switch for the earth connection anyway, and even if you just left it in the box there, of course you're not connecting to this in any way, and therefore because the screws come through to the front, that would then be an exposed conductive part. So light switches, you definitely do need to connect that, and the answer to it really is that for most everything else, although theoretically not needed, you probably should. Now there's a variety of methods you could use to connect to this. The first method here we're going to show is where you're going to leave one of the cables quite a bit longer than the other. This one here is about the right sort of length to connect to your socket or whatever. Generally want it to reach to all 4 corners of the box there. Don't do it as some people have seen where they've sort of cut it off ultra short so it just about reaches. That's a complete fail. So you only want a decent length like that. But if you leave the other one long, as we've got here, then what you can do is to, rather than cut a separate piece to go into this terminal, you can actually use the same one, put a fold in it and go into the terminal, and then you've got plenty left to connect to the accessory itself. So in the case of this one, we'll just leave a sensible length there. This is sleeving, because cable in the UK generally doesn't come with any covering on that sleeving, which is a bit annoying. That might change in the future. You can always hope for these things. So Slide that down over that one. We're going to put a bit of a bend into the wire there. And then once you've got that, this is what then goes under the terminal at the back there. So we can insert that into that. So we'll just tighten that up there. And then that still leaves you a sensible length to actually put into the back of the socket there. And again, of course, you would need a length of the sleeving over that as well. So again, that can go right up into the corner there. These two, and this is where the disadvantage is, these two are now actually far too long, so of course you would want to be cutting those down to a more sensible length. And this is the disadvantage with this method, in that it does create a certain amount of waste. So you've got this sort of length here of the two conductors, which you don't actually need. So multiply by over a whole house worth of sockets or something, then there is a certain amount of waste involved. And then you've got your conductors there to connect to your socket. And of course the other protective conductor here would need some sleeving over it as well, just as with the other one. So two there, the two neutrals, and of course the two lines as well. Now that's one possible method. You don't have to use that, and if you don't like it, well, don't use it. So it goes in there, and it's a single conductor, so you're not actually cutting or breaking anything. Because if you're breaking a conductor or cutting it, then that introduces a possible point of failure. So that was one method. Now another method, which is what I generally do and what a lot of people also do, is to cut all the conductors here to an appropriate length to connect to the socket or whatever else you've got. So pretty much all the same kind of length there. And again, you need that sleeving over the protective conductor. And then for the connection to the back here, you just use a separate conductor. Now this you can just buy as a roll of this. This is 1.5 millimeters squared, and it's sold mainly for conduit use, but it's ideal for this because it's the same size as the protective conductors within this cable, which is commonly used for socket outlets. So basically getting a piece of this, stripping the end of course to fit into the earth terminal there. And then it's just a question of cutting an appropriate length so it's a similar size to the others. So just cut off a piece of that there. And in terms of the end here, depending on the size of this, you may want to fold over the end of this. Again, it depends on how big the wires are relative to the terminal that you have. Now, whether you fold the end over or not depends really on the size of the terminal relative to the size of the wire. Now, in this case, it's a moderately reasonable size of terminal, but there's only a single wire going in, so fold it over in that case. That will probably fill up the terminal somewhat better than just putting a single one in there. So we'll put that in there and then just tighten that down. And then we've got our additional end here, and of course that would need to be stripped as appropriate. And then we've got our three protective conductors here, two for the actual circuit, another one for the back box, and then obviously the two others there for the line and neutral, which will go into the back of the socket. And of course the other way is to not bother with any of that and just leave that terminal empty and just rely on the fixing screw here, which in theory is okay with a fixed lug, but in reality that's a bit crap and not really the best choice. And although this shouldn't happen, it happens quite often. People take the socket off the wall whilst it's still live to decorate behind it, for example, and then of course as soon as you've undone it there's no connection to the box whatsoever. So although that shouldn't happen, and of course people should turn it off before removing stuff, in reality that may not always be the case. But of course if we've got this extra wire here, then that means it's always going to be connected no matter what. Now there is a circumstance where you will need to do this and add the wire like this, and that's where you would have a conduit system with the wires coming in. So what you would have there is the same conductors here, your line and neutral there, but these wouldn't actually exist. So all you would have is essentially these two coming out of the conduit, and then the steel conduit itself would form the protective conductor. Now in the case of that one you can't rely on the screw, and that is stated in the wiring regulations. So for a conduit system using the conduit as the protective conductor, you do definitely need to put this in here from the back there going into the accessory on the front. But in reality doing this is a much better choice anyhow, and let's face it, the cost of this is what, like 1 penny per accessory there. Marginal amount of extra time to connect it to the thing there, but pretty much nothing at all in the general scheme of things. Now, while I've got this here, I may as well just have a look at putting these wires into the terminals on, say, this socket, for example. Now, we're going to bring wires into the box here. You want to make sure that the grey, or whatever colour the outer covering is, does actually go into the box by a short distance. What you don't want is for these to be disappearing away there, and you've only got the coloured bits and then they go outside the box. Now, these are quite loose because this is just a demonstration board, but generally those would be fairly solidly fixed in the wall. So when cutting it back, you don't want to cut it so it goes right down outside of the box. And also you need this grommet here, which is a plastic piece, because these are made of metal and the edges of it where you take out the holes are very sharp. So without that, any slight movement on that and it's going to slice into those conductors and cause a fault. So fairly obvious there. And as we saw earlier, these are not supplied, sadly, without the insulation on the protective conductor. That's how it's supplied by the cable. Those are insulated, this is not, so it is necessary to put this sleeving over that particular conductor. Some countries have all three insulated, and it would probably be better if we had those over here, but certainly at the moment cable does not come like that. So put that over there, better to identify that, and also to stop this bare wire coming into contact with other things in there that it shouldn't do. Bearing in mind, on the back of your typical socket, you've got screw terminals and things there, so if this was bare and you pressed it back in there, there's a good possibility of it shorting out onto things that it shouldn't do. So it just goes over those like that. Now, if I look at the back of this particular socket, fairly typical one, this has been used, so it's a bit scratched up. But we can see on the back there, we've got our line and neutral terminals marked there, L and N, and also these are colour-coded with brown and blue on there for the appropriate colours. Now this one does have the straps going over to both sides where the screw fixings go, and that's again pretty common. And this has two earth terminals there, one here and one over there. Now both of these are linked together primarily by this metal strap that goes all the way across the top. So when you're fitting this to the wall, you can either use either this one, or you can use both if you want to. It doesn't really make a lot of difference in this particular application. There are situations where you might need to use both and have separate conductors going to those, but that's not a normal situation. That's only in a very few and limited number of applications. So just really whatever's convenient. And then the next thing is size of the holes relevant to the sizes of conductors you've got. Now, when you put the wires in here, the idea would be to make sure that whatever wires you've got fill up the terminal hole. Now, to show an example of that, there's the line terminal there with the screw removed. This wire, compared to that terminal, is quite large, so you see there's a lot of extra space going on in there. So just putting a single conductor there would not be a particularly good idea because it's only taking up, sort of a quarter of the space or less. And when you tighten the screw down, it may not actually bite onto that quite as well as it should. And there's also a possibility in some ones, these aren't a particularly good example of that, but where the conductor could actually go at the side of the screw and not be clamped properly by it. So the idea is to fill up the terminal as much as possible. Now, if you've got two wires, which generally is the case for most sockets, unless it's the end of a radial or a spur from a ring final, of course you're going to have two conductors there, and then there'll be two conductors in the terminal there. But again, there's still a lot of actual space there, so you could probably get another 3 or 4 in there if you really tried. Now, the usual way to get more copper in the terminal, as it were, is to fold these over at the end. So hence this has been cut obviously too long for those terminals. So the idea would be just to, let's say, fold that in half, and then instead of a single piece at the end, you've now got a doubled over piece like that. And you can do that on both of them, of course, so then they would go in the terminal and hopefully fill that somewhat better. So again, got our terminal here, the line at the bottom there. They'll still fit in there perfectly well, but the point is that when they're in there, it's filling up that terminal a lot better. You can see just the ends of the folded over bits there. So when the screw goes down, it's actually biting onto effectively double the amount of copper that was in there. And the other thing to make sure is that when the wires are in, you've only got insulation basically showing through on the outside. You don't have any bare copper sticking out of whatever style or type. So again, we'll just tighten up the screw on that one. So these are a bit chewed already because they've been used several times, and you want to tighten that down with a goodly amount of force. There are no torque settings for these, unlike consumer units, and the reason for that is that manufacturers don't specify any. So if manufacturers one day said that our sockets need to be tightened up to 2 Newton meters, then you would have to go and do that. But let's not give them too many ideas. So that's in the terminal there, and you can see on the side insulation goes all the way up to the terminal, and we've got our folded over bits in there, so it's pretty much filled up with copper there. And you wouldn't normally pull on this in normal installation, but you can actually give that a good old wrench there, and it's not going to be coming out of there. And I say normally you wouldn't pull it like that, obviously, just make sure it was securely fitted. So most of the time you want to fold it over, because usually the terminals are quite big in relevance to the wire. However, there are a few cases where you might not want to. If you say had 3 wires in here, you might find that if they're all folded over they don't actually fit, in which case you wouldn't necessarily need to do that. And if there were, say, 4 wires in there, which would be getting towards a ridiculous situation, then almost inevitable that you wouldn't be able to fold them over. So really it's just a question of wire size compared to the terminal size, and generally try and fill it up as much as possible by folding over if actually necessary. This is actually an MK one, and again if we just put the wire there, you'll see again that's quite small in terms of wire compared to terminal size, so same kind of thing with that one. And again, even this light switch here, it's quite a big terminal there, and this is obviously far too big for a light switch, but again you can see that wire size relative to the terminal is still pretty big there, so just a question of what's relevant and appropriate. One thing to watch out for, particularly on lighting, is that dimmer switches often have extremely small terminals, and on those you may not even be able to get a single one in that's folded over, because they manufacture those seem to like the extra tiny terminals on those. So I'll just do the rest of these wires here while we've got this thing here. So again, just fold over the end of the wire there, and of course we'll do the same with the other one as well. Tools used for this is a matter of personal choosing. I happen to use these yellow efforts and this unsafe to some people knife with the fixed blade, but you may use other things. And the protective conductor here, this is actually thinner on this style of cable. These are 2.5 millimeters squared, and this is only 1.5, so certainly necessary to fold these over. As of course they are considerably thinner to start with. And again, just make sure that's covered over like that. This is a stranded one, so we'll just twist that up a bit to start with, and we'll obviously fold that over as well. Generally a bit more flexible, just do that with the fingers there. I'll just put the other wires in there, so neutrals here, the lines there, and the protective conductors over here. Now this one to the back box you can put in there with those if you want to, it doesn't particularly matter, or you can also put it over here, obviously onto the terminal we have there. So bearing in mind both of these are connected together anyhow, so it really doesn't make a whole pile of difference whichever one you're using, just as long as it's going into at least one of them. Just really a matter of what's most convenient at the time. So we'll put it into that one over there in this particular case. We'll make sure those are properly tightened up there. And I say these, how tight is really just a matter of practicing and actually doing it. So there aren't really any torque settings for that. So that's all wired up there, and you want to fold the wires around so they go fairly neatly into the box there. The main thing there is to avoid it going where the screws go in, so if this goes underneath, when you put the screw in it could damage the insulation and obviously cause a fault, so you want to be avoiding that. And other than that, it's just folding around fairly neatly, sort of bend them into position there, and then obviously this will just go down onto the box like that. And then your screws go in the holes either side to secure that in position. And so that one is a fixed one, and this one has a bit of movement there, so you can obviously get it nice and level. So that's back boxes and whether you need a piece of wire from the box to the earth terminal. And the answer is theoretically no, if you want to do the absolute minimum and rely on that fixed lug connection. But in reality, far better to actually use a few pence of wire and a few moments of just time to put that in there. And again, bearing in mind that covers a situation as well where people take these off when they're live, which of course shouldn't happen, but unfortunately probably happens quite often, certainly for decorating and whatever purposes. So put the thing in there, it doesn't take any extra time really, and it's a few pence for a piece of wire like that. Now, if you've got a plastic box like these sometimes do have a terminal in the corner. These ones particularly don't, but you do see that occasionally. That, of course, does not need any connection to it because it's plastic. Plastic items obviously are insulating, no point in connecting anything to them. However, the reason that's in there is so that when you've got something like a light switch, say this one, plastic light switches don't generally have earth terminals on the back. So for those, then you can just use that terminal in the back there just as a convenient place to put the conductor. If it's not there, you can obviously just supply your own terminal. And of course, metal light switches do require an earth connection, and they will have the earth terminal on the back. So then that's exactly the same as having a socket or other accessory with an earth connection. So that's pretty much it for this video. Until next time, thanks for watching.